Scroll through any online marketplace and you will see thousands of listings for articulated dragons, geometric phone stands, and visually satisfying fidget toys. They are mesmerizing to watch form, layer by layer, on a print bed. Because these items generate millions of views and likes on social media, new sellers naturally assume they represent a highly profitable business opportunity. This chart illustrates the economic reality. When anyone with a $200 machine can produce the exact same dragon, the market floods. Sellers undercut each other until the retail price plummets to match the raw material cost. In this ecosystem, a best-selling item that tops the search results is rarely the most profitable one for the person actually printing it. Traditional mass manufacturing relies on heavy steel injection molds. To justify the hundreds of thousands of dollars required to cut that steel, a factory has to produce millions of identical wheels, demanding universal consumer appeal. Desktop 3D printing operates on a different logic. The highest margins exist in the manufacturing blind spot, highly specific, underserved niches that billion-dollar factories are economically forced to ignore. One major blind spot opens up when a physical product simply ages out of the market. Once a specific appliance or piece of hardware reaches a certain age, manufacturers stop running the injection molds for its spare parts. They shut down the assembly line, leaving consumers stranded when a minor component breaks. Take a specific plastic bracket on a pair of discontinued studio headphones. Without that small hinge, a valuable piece of audio equipment becomes completely useless. This balancing scale explains why the operator commands a high price. On one side, the 3D printed plastic bracket requires only 50 cents in raw material. On the other side is the $200 cost of throwing out the hardware and buying a new pair. The operator charges for the financial rescue they provide, pricing their work based on the value of the problem solved rather than the weight of the plastic used. A second blind spot exists in unique one-off creations. Mass manufacturing rejects absolute personalization because it requires stopping the assembly line for every new unit. In tabletop gaming communities, players spend hours designing their own unique characters. Because these designs lack mass appeal, they do not exist on retail shelves. The jewelry industry faces a similar demand for bespoke creations. High-precision resin printing has replaced traditional hand carving to create master molds for small batch casting. This level of customization eliminates market competition entirely. When you provide the only physical version of a client's specific design, you can command 80 to 95% profit margins. Maintaining those margins is a prerequisite for survival. Sellers often overlook the hidden overhead of production, the electricity to heat a printer, the depreciation of moving parts, and the labor of post-processing. The average failure rate for FDM printing hovers between 5 and 15%. With razor-thin margins, a single failed print erases the profits from 10 successful ones. Conversely, reducing that failure rate to 3% recovers thousands of dollars in net margin annually. Locating high-value, specific niches acts as an operational shield. It provides the margin necessary to absorb the inevitable realities and physical failures of manufacturing. Once a high-margin niche is secured, the operation graduates from a single hobbyist machine into a synchronized, decentralized print farm. When each printer in a fleet yields $20 to $40 of product per day, an operator running 8 to 20 machines reaches a significant financial threshold, generating $6,000 to $12,000 in monthly revenue. This scale hits a high-efficiency sweet spot. It captures meaningful production volume, but stays small enough that the owner avoids the overhead of leasing commercial real estate or hiring full-time employees. This is a highly agile microfactory. It can pivot to a new product design overnight, adapting to market demands months before traditional overseas supply chains can even begin cutting a mold. A 3D printer is merely a tool. Technical skills like leveling a print bed are secondary requirements, compared to the ability to analyze a market. The true skill in this industry involves looking at the physical world and identifying the exact specific problems that billion-dollar factories leave behind. Those problems are actively felt by passionate communities. Makers, hobbyists, and repair professionals rely entirely on independent microfactories to keep their specialized projects and niche hobbies alive. The most successful operators don't focus on printing what everyone already wants. They build their businesses by finding the missing piece no one else is willing to make.